So we don't really think of sugar as a hydrocarbon, but if you notice when we are working with the material and the definitions, sugar, any number of C's, any number of H's, any number of O's, and the O's can be zero. In this case, we have 12 C's, 22 H's, and 11 O's. So it can be combusted or burned and using that same process. Remember, when it says burns, it means the other reactant is going to be oxygen gas. And our products for any combustion, for hydrocarbon combustion, are going to be carbon dioxide and water. When you are doing these problems, always balance it so that you get the most information. Even on the quiz, if it doesn't ask you to balance it, it might still want you to balance it to make sure you are selecting the right product for the item. So let's rewrite that out here. C12, H22, O11 plus oxygen gas. We know this is sugar, so I'm going to assume it's in sugar form and not aqueous form. So I'm going to put a solid there. And that's going to come into carbon dioxide gas and water vapor, water gas. As we said, anytime you see this process, CXHY plus OZ plus O2 yields CO2 plus H2O. That is going to be your hydrocarbon combustion, so we have to balance in alphabetical order. 12 C's. So we have one C currently on the right. We need a 12. 12 times 1 gives us 12 on the right. Hydrogens, 22 on the left. And we need something times 2 is 22. 11 times 2 is 22. So we now have 22 on the right. Oxygens is tricky. It's not only in 2 places on the product side, it is in 2 places on the reactant side. Okay. So let's count them out. In sugar, we have 11. And in oxygen gas, we have 2 for 13. That one's a real iffy number because we know we're going to be changing at least one, if not both of those coefficients. How about on the right side, oxygens? 12 times 2 in this case for 24. Carbon dioxide has 2 oxygens for every 1 carbon. Water has 1 oxygen for every 2 hydrogens. So in this case, it's 11 times 1 or 11. 24 plus 11 oxygens on the right is 35 oxygens on the right. Now, when we're looking at this, what do we need to do? We have 35 we need to come up with. But I have 2 oxygens in 2 spots. Start with the one that is more complicated. Why is this more complicated? Because it has carbons and hydrogens there. Okay. If I put a coefficient in front here, it's going to mess up my carbons and it's going to mess up my hydrogens. So it's going to be a lot more work to try to get my balancing taken care of. So what do I have? I have 11 here. How many do I need to have total? 35. So 35 minus 11 is 24. So the other oxygen guy needs to give me a total of 24. Something times 2 is 24. 12 times 2 is 24. 24 plus 11 is now 35. So let's double check, because sometimes I have issues. 1, 12, 12, 11. 1, 12, H, 22, O, 11. Plus 12 oxygens. Plus 12 carbon dioxides and 11 waters. All right. Double check time. 1 times 12, 12. 12 times 1, 12. Hydrogens, 1 times 22, 22. 11 times 2, 22. Oxygens, 1 times 11, 11. 12 times 2, 24, for a total of 35. 12 times 2, 24. 11 times 1, 11. 24 plus 11, 35. It's not always just going to be switching those numbers around. So don't assume that you can find a rule just because of one instance. That is anecdotal. That is not any bit of scientific proof. When we become and find theories about things, then we have lots of information to justify it, but we don't have a firm answer yet. When we have a law in science, it means every single time we do A, B happens, and here's the math to prove it. So just because we see some little coincidence here of the 11 and the 24 does not mean that that is always it. Now, what is the rule we follow to make this? Conservation of mass. Same number of each element has to be on the reactant side and the product side. What is the reactant side again? On the left. What is the product side again? On the right side. Our reactants are ingredients to find our products. And that's all for today.